Hello students, and today we're going to be taking a look at solving right-angled triangles. So what does that mean? Well, our goal is to be able to find the length of any missing side of a right-angled triangle. And that's what it means to solve, to be able to determine what all measurements are. So I've got a bit of a flow chart here to help us out. So let's take a look. How many side lengths do you know? Well, if you know no side lengths in a right-angled triangle, it's not possible to solve. If you know two side lengths in a right-angled triangle, you can use Pythagoras' theorem in order to find out what the third missing side is. So if you know one of those sides, but you don't know an angle, it's not possible to solve. But this route here of knowing one side and one of your acute angles is what trigonometry is all about. So the idea is if we know one side length and we know one of the acute angles, we can use our trigonometric ratios to solve. So let's take a look at an example here. So what we've got is a triangle. We've got one side length and we have one internal angle here, one of our acute angles. So with all trigonometric problems, what we're going to start off with is labeling our sides. So we've got our opposite side, we've got our adjacent side, and we've got our hypotenuse. So what we want to do is we want to take a catalog of the information that we have. Well, x is our opposite side. Finish that up there. Y, this is our adjacent side, and the side that's 14.2 centimeters, well, this is our hypotenuse. So now that we've got kind of a catalog of the information that we have, let's take a look. Well, we know the hypotenuse. So our known side is going to tell us kind of our course of action here. So I have to use one of my ratios that has hypotenuse being a part of it. So let's take a look here. Let's find out what the sine of 52 and the cos of 52 are. So bring up the black pen here. So if I have the sine of 52 degrees, well, this is opposite over hypotenuse. So in this case, this is x over 14.2. And if I take the cos of 52 degrees, I get adjacent over hypotenuse, and we get y over 14.2. So notice for these two statements here, we only have one unknown. And when we have one unknown, we can use algebra to solve. So what we're going to do is we're going to take a look at sine first. So the sine of 52 is equal to x divided by 14.2. So let's start off here. What's being done to x? Well, it's being divided by 14.2. What's the opposite of dividing by 14.2? Multiplying by 14.2. So we're going to use our SAMDEB approach. That's just undoing what's being done to x. So let's see what we get here. This is going to give us 14.2 times the sine of 52 degrees is exactly equal to our value x. Now what we might want to do is find out what x is, let's say, to one decimal place. We're going to use our approximation symbol here. So if we type this into our calculator, what we're going to get is to one decimal place of accuracy, we get 11.2. And because the 14.2 is given in centimeters, this length here will also be given in centimeters. So let's take a look at cos. I want you to try this out on your own now. So pause the video. Okay, so what is our first step going to be? Well, we're going to start off by multiplying by 14.2 on both sides. So right afterwards, we have 14.2 times the cos of 52 degrees is equal to y. And punching this into your calculator, 14.2 times the cos of 52, accurate to one decimal place, you get 8.7. And again, this unit's in centimeters. So what I'm going to be taking a look at the beginning of our next video is how can you check to confirm that this answer is correct.